everyone. In this lesson, you're going to learn how to write an exponential model from a set of points. We're going to be looking at exponential models to see if they're a good fit for data. And we're also going to be learning how to use the calculator to come up with exponential and logarithmic models. So the first thing we're going to do is we're going to write an exponential model given 2 points. An exponential model comes in the form y equals ab to the x. If we have a value of b greater than 1, we knew that it was growth. And if we have a value of b between 0 and 1, we knew that we had decay. Just a little reminder there. So just keep in mind that that value of b has to be greater than 0. So we have 2 points, and we're going to just take one of the points and fit it into the model. So we have 0 and 3, so this is our x and y, and our model is y equals ab to the x. So I'm going to replace y with 3, and I'm going to replace x with 0. Now, anything to the 0 power is 1, so b to the 0 power is 1, so I'm just left with a equals 3. Now, the other equation that I could write, given this 2 and this 12, again, we've got y equals ab to the x, y is 12, and x is 2. Now, I already know that a is equal to 3, so I'm going to replace the a value right here with the value of 3, because I know a is equal to 3. All right, to solve now for b squared, we're going to divide both sides by 3. And we're going to get, now, when we take the square root of both sides, algebraically we get the values of plus or minus 2. But as I've already noted, the value of b is going to have to be greater than 0. The only value of b that's going to work is 2. So we're being asked to write the model, ab to the x, and we know that our value of a is 3, and our value of b is 2. So our final answer here is y equals 3, 2 to the x power. Now at this point, I would say pause the video and see if you could do number 2 on your own, but just be forewarned, number 2 is a little bit harder to do. So we have a set of points here. We've got our first point, y is 4, and x is 1. Oh, okay, so I have, what do I really have? I have 4 equals ab. Well, I got to solve for one of them so I can substitute that into my next equation. So I'm just going to solve for a again, just like I did in the last equation. So that means that I would have to divide both sides by b. All right, now my other equation for this point, in this case y is 12, and b is 2. Now, I'm going to substitute in what I found for a, and I know that a is 4 over b, so I'm going to replace a in my second equation with 4 over b. So let's write that out. So 12 equals 4 over b times b squared. Right, now the next thing is we have to just simplify this. So we've got 12 equals, you could rewrite this, think of it this way, b squared over b. That means the same thing. Now what's b squared divided by b to the first? When we are dividing, property of exponents tells us that we would say that you're going to subtract the exponents. So that we would end up with 12 equals 4b to the first. That's b squared divided by b to the first just gives me b to the first. To solve for b, I would divide both sides by 4. And so now I have 3 equals b. So I know that a is 4 over b. So I'm going to say a is equal to, we know it's 4 over b, or in this case, now that we know b is 3, A is equal to 4/3. So the last step then is just like in the last problem to write out my model. Well, my model is in the form y equals AB to the x. We know that A is 4/3, and we know that B is 3. So our model is y equals 4/3, 3 to the x. The coefficient of determination in regression, the coefficient of determination, which is r squared, represented by r squared, measures how well a graph approximates the real data point. So it tells us how well a model fits a set of data. And r squared equal to 1 indicates that the regression graph perfectly fits the data. And if it's not close to 1, we know that it's going to be a very low correlation or no correlation. So let's take a look at some examples so you can see what I mean. The table below shows a recent graduate's credit card balance each month after graduation. Use exponential regression to determine a model for this data. All right, so as a reminder, we've done regression in the past, but as a reminder, we're going to open our calculator, and you're going to be using your calculator for the rest of this lesson, so please make sure you have it handy. You need to practice entering all these steps. We're going to go to Stat, Enter. And I already have some data in there, so best practice would be to just clear my list. So I'm going to quit out of here, second mode, and I'm going to clear all my lists. So I'm going to do second plus sign, and you're going to choose number 4 for clear all lists. Always a good habit to do anytime you're going to start a new regression problem. All right, we're going to go back to Stat. We're going to hit Edit. We're going to go over to List 1, and we're going to enter the data from List 1, which would be our months. Okay, once I have our months entered, we're going to go over and we're going to enter the debt column, how much our recent graduate owes in credit card debt. All right, double check your data, make sure everything is entered correctly, and then we're going to do second mode to quit out of the list. And now we're going to do the exponential regression. So you're going to go to Stat, you're going to go to Calc, and we're going to pick 0 EXP Reg. So scroll down to 0. Or you can actually just press 0, hit Enter. Make sure your list, your X list is list 1. If it's not, you're going to do second 1 for list 1, second 2 for list 2. Frequency list should be clear, nothing. We're not going to store this for now. And we're going to calculate. So hit Enter. We're not going to round at all. Rounding will affect any kind of prediction you make, so we're not going to round at all. All right, so that's our exponential model based on this data. Now it says using the coefficient of determination, r squared, determine if this model is a good fit. Now you should have gotten an r squared value when you did the regression. If you didn't, you need to turn diagnostics on, so I'll just take a second to show you that. We're going to go to second 0 for catalog, and when you open the catalog, you'll notice that the letter A is up here. That means we're now in alpha mode, so we can scroll down to whatever letter we want. We want to scroll down to letter D for diagnostics on, and you can see there's a D right with that button. That'll at least take us down to the D's, and then we can scroll a little quicker to diagnostics on. And then we're going to hit Enter, and you have to hit Enter twice. So now when you do the modeling, I'll just repeat it, second Enter to get that command back. You should see the r squared value. So we want to write down what the r squared value is, and we'll round 3 decimal places out here. So 0.998, let's write that down. And we want to determine if it's a good fit. Well, the closer we are to 1, the better the fit. So it says, is this model a good fit? And the answer would be yes, it's almost a perfect fit. Now, what do I mean by almost a perfect fit? We can go to look at the graph in our calculator, first of all. So we would turn stat plot on. We have a scatter plot, and we're going to do zoom 9 for statistics. So that's our data. Now I have some equations in here from prior lesson. I'm just going to clear those out. Let's go back to the graph. Again, that's our data. Now, if we put our model in, we should see that it almost hits every point perfectly. So we're going to quit out of here. I'm going to go back to my model. And this time, I'm going to store my model. I'm going to hit 0 in Y1 so I can see what happens, what the model looks like against our data. So I'm going to tell it to store my regression equation in Y1. So I'm going to go to vars, yvars, enter, enter, and now it'll store that equation in my y equals. So if I go to y equals, there it is. I don't want to have to type it. And now if I look at the graph, you could see that model running through the graph. And you can see what I mean by it's almost a perfect fit. Just one point right here, maybe it's a little off, but it's almost a perfect fit for our data. If spending continues at this rate, what will the graduate's credit card debt be 1 year after graduating? So when we get into month 12, what's going to happen to this poor person? All right, so if we input a value of 12 into that equation, what's that going to mean? Well, we could look at our table of values. I've stored my equation. You could type it or store it the way I showed you. You would type the equation. And then we could look at the table of values. We'll go to second graph to look at the table of values. And we want to know what's the value, what's the debt at month 12. So at month 12, looks like we're at about $4,499.40 in debt. So we've come up with a model, and then we've used our model to make a prediction with our data. In 2007, a university study was published investigating the crash risk of alcohol-impaired driving. Data from 2,871 crashes were used to measure the association of a person's blood alcohol level, their BAC, with the risk of being in an accident. The accident risk is a measure of how many more times likely a person is to crash. So for example, if you have a blood alcohol content or level of 0.09, according to this chart, you're going to be 3.54 times as likely to crash as a person who has not been drinking. So it says let X represent our BAC level and Y will represent the corresponding risk. Use exponential regression to fit a model to this data. All right, so we'll go back to our calculator. We're going to quit out of here, and we're going to clear all our lists. Second plus sign, number 4. We go to stat, we go to edit, and we're going to enter our data into our lists. Okay, now that we have our data entered, we're going to quit second mode. We're going to go back to stat, calc, and we're doing exponential regression. So we're going to choose 0, or you can scroll down to it. Hit enter. Second 1 for list 1. You don't have to do this if it's already there. Second 2 for list 2. Since I know in this question I'll be asked to make a prediction, I'm going to store this regression equation into Y1. So we're going to go to vars, yvars, enter, enter. If you don't do that, your old equation will still be there. And we're going to hit calculate. All right, so there's our equation. We're going to write it down without rounding. Using the coefficient of determination, determine if this model is a good fit for the data. Well, we see that our R-squared value is 0.921, so let's write that down. And 0.921 0.921 is really close to 1, so we're going to say yes, this is a very good fit. After 6 drinks, a person weighing 160 pounds will have a blood alcohol content of 0.16. How many times more likely is a person with this weight to crash if they drive after having a 6-pack of beer? Round to the nearest hundredth. So we want to know, we're going to put in a value of 0.16, so blood alcohol content of 0.16. We want to know how much more times likely are they to have a crash because of the alcohol in their system. So we'll go to our table of values because we have automatically put our equation into y equals. So now we can just go second graph to look at our table of values. Now, I have my table set up right now in increments of 1. That's not going to really help me because I have 0.16. So I'm going to go to table set, second window to table set, and I'm going to have the table just start at the value I want, 0.16. All right, and then I'll go back to my table, second graph, and it'll just show up, and then it'll still do increments of 1. I could change that, but all I really care about is this value at 0.16. So 15.911 times more likely. It says round to the nearest hundredth, so 15.91 times more likely. All right, number 5, due to advances in medicine and higher standards of living, life expectancy has been increasing in most developed countries since the beginning of the 20th century. The table below shows the average life expectancies in years of Americans from 1900 to 1970. All right, so we have our table of data here. And notice we have years, all right? And a lot of times when we have years, we don't put the year in for the x value. So it says right here, let x represent time in decades starting with x equals 1 for 1900, x equals 2 for 1910, and so on. All right, so I'm going to make a note up here. So 1900 is x equals 1. 1910 then is x equals 2. 1920 is x equals 3, and so on. Right, now this time we're being asked to use a logarithmic regression to fit a model to these data points. So we're going to go back to our calculator. We're going to do second plus sign to clear all lists. We'll go to stat, enter, and we're going to enter in our data using the values for x from 1 through 8. Don't use the years. Now we'll quit out of here. We're going to go to stat, calc, and this time we're going to choose logarithmic regression, which is the LNREG, number 9. So you can either press number 9 or you can scroll down and select number 9. And make sure you have list 1, second 1, list 2, second 2. And we're going to store the regression equation. So we're going to go to vars, y vars, enter, enter, and we'll calculate, and we'll write that equation down without rounding. It says use the model to predict the average American life expectancy for the year 2030. All right, so 2030, our x value then would be 14. So we put 14 into our equation. We could either enter 14 in manually, or the easiest way to do it is to go to our calculator. I'm going to go to second window to set my table value at 14 to my start value at 14. Second graph to look at the table, and I get a value of 76.753. And that would be my life expectancy at 2030. Gotta admit, I was hoping that'd be a little bit more than 76. All right, number 6, sales of a video game released in the year 2000 took off at first, but then steadily slowed as time moved on. The table below shows the number of games sold in thousands from the years 2000 to 2007. Again, we're going to let x represent time in years, starting with x equals 1, and then so forth from there. So let's write that in. All right, and the numbers sold we have here, so we're going to put our data in. Now I'm going to go to Stat Edit, and since I already have list 1 entered, I'm going to be a little lazy this time. I'm not going to clear my list because I don't feel like entering list 1 again. I'm just going to go up to the top at list 2, and I'm going to hit clear. Do not hit delete. If you hit delete, you'll delete your list. You'll have to reinsert it. So we're going to hit clear, and I'm going to hit enter, and now I have a clear list for list 2, and I'll enter my data. All right, once I have my data entered, this time we're being asked to find a logarithmic model, so we're going to go to Stat Calc. We're going to choose number 9. We're going to store the equation. Again, vars, y-vars, enter, enter. I'm going to do calculate. We'll write that model down without rounding. It says, if games continue to sell at this rate, how many games will sell in 2015? So that would mean we need to input a value of 16 for the year 2015. So we're going to go back to our calculator. We're going to go to second window. I'm going to set my table for start at 16. I'm just being very lazy now. Second graph, and I get a value of 171.31. So what does that mean in terms of this problem? That means that about 171,000 games are predicted to sell in 2015. Okay, everyone, that's it for this video. Thanks for watching this one to the end. Have a great day.